name is AINI FATHIHAH binti Muhammad Zakri. My matric number is B0819103665.
My name is AINUL BALQIS binti. My matrix number is B0819102226.
Hello, Assalamualaikum. Today, I and my partner will show the result for the lab 6 of DC motor, servo motor and stepper motor. My name is AINUL BALQIS binti and my partner is AINI FATHIHAH binti.
For the part 1, simulation is DC motor. This simulation use DC motor, Arduino Uno and motor driver. And this part 1 they have coding. Okay, for the part 1 we use Arduino Uno, motor driver and motor DC motor. Once we start the simulation, we can see on we start the simulation, we can see motor driver is stopped, and when we push the push button, the motor driver will turn. Okay, this is for the part 1, and then we proceed to the part 1 exercise. Okay, for the part 1 exercise, we use the same simulation. We use the same Arduino Uno. We use the same schematic, and we just we want to switch one become start or stop switch, and when we press switch one, the motor DC is run, and when we press switch one, we stop the motor. We can see the motor can be adjusted by variable resistor. Okay, this is for part 1 exercise. Okay. Okay, we can see this simulation. When we press switch 1, when we press this switch 1, the motor driver is run. We don't press the switch, the motor driver will stop, and then we can control motor driver turn with the variable resistor. Okay, we can see when we adjust the variable resistor, the DC motor will turn. We can see the speed of the DC motor. This is part 1 exercise. Okay, we can proceed to AINUL for part 2.
So next for the part 2. For the part 2, we want to simulate the servo motor. So for the servo motor circuit, we use Arduino Uno and servo motor and variable resistance. So for the servo motor, we can adjust the angle, which is the minimum angle and maximum angle. So when we click the double click for the servo motor, so we can change the minimum angle and maximum angle. But for the part 1, we need to change the voltage in the voltage variable. So what can we observe is when the maximum potential meter is 5 volt, the motor servo will turn almost 118 degrees, while when potentiometer is 0 volt, the motor servo will turn almost 0 degree, and the movement of motor servo depend on the value of potentiometer. Okay, so when we run, you see when it came. So now we can change, we want to change the voltage in 4.5. 4.5. And the result you can see in the servo motor, you can get (165 angle). Okay, and for if once if we change the voltage in a minimum voltage, minimum output, which is 1.2 volt. So the servo motor get the 44.9 or some 44.8 angle. So this is what we observe for the part 2. Next we go to the what we can conclude is when we run the simulation, the servo motor turn 0 degree, and after 2 seconds the servo turn into 19 degrees. Then the servo motor will turn for condition 180 degree, 90 degree and 0 degree for every 2 seconds. So this is the coding. So you can see almost in every 2 seconds the servo motor will rotate in degree that we set on the coding. Okay, next for the exercise, by using servo H library, write a program code that will rotate the servo motor based on potentiometer. So I have to try the coding. So let's see it's work or not. So try the coding. So that we can change the servo motor based on potentiometer. So next I will proceed to the part 3. And next for the simulation for the part 3, we use a stepper motor. For the circuit, we use Arduino Uno, stepper motor and the battery. So how it works, we can observe that with default step in angle, the stepper motor will run in reverse direction, which is in 19 degrees for every sequence. Next, what can we observe? We can observe that stepper motor move in forward direction. This method required the least amount of energy and generate the smooth movement. Okay, so let's run the coding first to see how smooth the movement for the stepper motor. So once when we put the coding, you can see the stepper motor will move based on the sequence that we set in the coding, which is first the integer a is height, the sequence is height, low, 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 and then go to low, height, and low, low, and then for integer b we go low, low, height, and low, and then for last sequence is low, 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 and height. Okay. So next I will proceed to the exercise 3 to my partner.
Okay, for the exercise 3, we use the same schematic with the part 3, but we have to modify program at the stepper motor in reverse direction. Okay, this is the coding of the stepper motor in reverse direction. Okay, now we use the same schematic of part 3. We use Arduino Uno and stepper motor. In the coding, we just adjust for the direction of the stepper motor, that A bar, B and B bar. Okay, and this is when we run this machine. Ni tu. Okay, as we run the simulation, we can see the stepper motor will rotate in the reverse direction. Okay, we use this coding. We look it into the notes and that our lecturer bring it. Okay, this is the lecturer notes that represent about the what we call the kedudukan of the stepper motor for the reverse and forward direction. Did you see, Ainul?
Yes, it's clear.
Okay. This is the sequence of the stepper motor in the reverse direction and the forward direction. When now for the exercise exercise part 3, we want use for the reverse direction. For the reverse direction, we use for A bar plus the plus is what we call is high, negative is low. For A bar, we use high, low, low, low. For A bar, low, high, low, 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 and B low, low, high, low, and Beea is low, 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 and high. This is the sequence or stepper motor for the reverse direction for the part 3 exercise. That's all for the part lab C.